Hello and welcome back to this video series on theories and research methods as they pertain to academic writing. In this short video, I want to talk a little bit more about quantitative research and the rationale behind quantitative research. And if you're not into quantitative research, that's fine. This is helpful for understanding research when you hear it discussed in the news. Some news article comes out and says, a new study says this is good for you, or a new study says, oh, this is, good for kids. And well, do you believe it? Let me explain how scientific, especially quantitative research is done, whether it's in hard sciences, biology, or in psychology, or language research, or education research, medical and health research. We follow the scientific method. You've probably heard of that. You form a hypothesis, you test it. Based on the results, you either reject the hypothesis or you modify it and test it again, or reject it altogether. Let's say a little bit more about that. How does it work? Well, you compare groups, basically. In a lot of research, we compare groups. One group, let's say of people, they get whatever is the normal thing, or they get nothing, and that's your control group. And then the other group, which is your target or experimental or study group, they get something new, the thing that you're testing, whether it's a new drug or a new teaching method or some psychological stimulus or whatever. You have a control group and a treatment group. So let's say, for example, we are testing language learning, and we are going to measure some kind of outcome. You measure some kind of outcome or result variable. Maybe it's test scores or improvement in test scores from between the start and the finish or something like that. And you have some kind of group or condition that you're looking at, and you want to see if something is true. Well, in comparing groups, you're also comparing hypotheses. Your research hypothesis maybe says, this new teaching method will lead to better learning of this grammar form. When we compare groups, we are also theoretically comparing hypotheses. My research hypothesis says this new teaching method is better. Now you compare that with kind of a null hypothesis. Null means zero, which represents the control group. The null hypothesis would be, in contrast, this new method does nothing different. It's no different from anything else. So you're comparing your research hypothesis with a null hypothesis by comparing two groups. You're comparing like the outcomes. So you get two groups, one where say you do the new teaching method, and one where they learn things in some normal standard way. That's a way of comparing groups and comparing hypotheses. And if I get different results in the test group where they got taught in some new way, then I conclude, well, there's evidence from my hypothesis that this new method works. If I don't see any difference, then I would reject my hypothesis and say there's no difference. This method doesn't work. You accept the null hypothesis. Variations on this, well, you compare two different groups. Is there a difference in how Japanese or Korean learners would learn this grammar form in, say, English or in Hungarian or whatever language you're teaching to these students? You compare groups, and you have some tests, some outcome, and you compare the results using statistical analysis that compare the groups in the various aspects of the data between, say, the Japanese and the Koreans. Or let's get a little more complicated. You can do this with statistics. If you have enough subjects, let's compare language group and, let's say, some personality variable that I think might affect things. We have, let's say, a bunch of Japanese students and a bunch of Korean students, and some of them are introverts and some of them are extroverts. We can give tests to check which they are and see if there's a difference in the outcome, see if personality and language group affects whatever I'm doing. A variation on this might be comparing the research hypothesis with the null by not having so much a control group, but kind of a baseline. So let's say I don't have necessarily a control group, but let's say I give some kind of a survey that checks students' motivation, their internal motivation for language learning. Then I look at their outcomes on some kind of a task, and the motivation is maybe some kind of score from 0 to 100 from a survey. So I'm not exactly comparing groups, but I'm comparing different scores for like the amount of teaching and the amount of motivation to some baseline of 0. And that's really a variation on the idea of comparing groups. And I do some sort of a correlation test to see if there's a correlation. The more motivation, the better they learn, compared to a baseline of like some really low or 0 motivation. So those are things that we do in research. Now, what's important, especially if you are reading a news article about some science or health or psychology news, what's important to understand is one study is not enough. Yeah, you go through the scientific method, you come up with the results and say, okay, my hypothesis is supported. Doesn't mean I've really proven it yet. Maybe I need to do a bigger study. Maybe I need to consider other possible factors. So after I do one study and I publish it, replication or follow-up experiments need to be done. Replication is important. Other people also need to do research. They need to check my methods, make sure I did things right. They need to make sure they get similar results. I and others are going to do follow-up studies and maybe test other possible factors or variables just to make sure there isn't any noise or there's something I didn't really consider that would mess up my results. And it's only after enough studies have accumulated that the community of scholars and researchers in this area will agree, okay, this is a thing. In medicine, it takes a number of multiple trials or tests for a new drug before the new drug is approved and can be sold. Or when it comes to, say, science and medical health news, a number of studies need to accumulate before, say, medical researchers will agree, okay, this is a thing. This is good for your stomach. This is bad for your heart, or whatever. So you don't listen to one news report about one single study. You need to consider, okay, what's the consensus of the medical community or the psychological community or the education community or the scientific community. One study doesn't prove something. We do the scientific method and we apply it again and again. We do multiple studies, and only as enough evidence accumulates do we then agree this is a thing. This is important whether you are looking at research, you're writing a research paper about some research topic that uses quantitative research, or if you're just a consumer and you're going to make buying decisions or decisions about your lifestyle or your eating habits based on some reports you hear in the news media. It's important to understand how this stuff works. I hope this helps. That's it for now. I'll see you in the next video. Goodbye.